Hey everyone, so this is the next video of the Riemann sum trapezoidal rule word problem where we are in the same situation in terms of the table, but we are now evaluating the Riemann sum using the right Riemann sum. And I actually want to kind of go back because I mentioned it, but I didn't really talk about it. Overestimation, underestimation. So in the previous problem, we did the left Riemann sum, and as you can see, this was a underestimation because the majority of the area is not filling up the curve. There's these little gaps here. So with that extra space, we are not accurately estimating, we are underestimating what the true area is. So with that being said, let's see what the right Riemann sum produces for us. So I'm going to sketch the same type of graph. This is for 1B. I'm going to sketch the same type of graph from 0 to 120, and I know that I am increasing as my as my x values go from left to right. And I know I'm skip counting by 20 because it is the same situation with the same table, so nothing changes there. So now when I'm developing my right Riemann sum rectangles, I'm not going to start on the left side of the rectangle, I'm starting on the right. So here's my A of t for total area. I'm going to sketch up from 20, hit the curve, and then I'm going to carry over to the left. So my first term is not going to be f of 0 like we did in the left Riemann sum, it'll be f of 20. So f of 20 times the width of 20 plus, and then boom, from 40, hit the curve, drop down. And you can already see that if I were to just shade in the curve that's strictly underneath the function, I already have this extra space going on. So I'm definitely going to have an overestimation in this problem. So multiply by 20, and then start here from 60, go over f of 60 times 20 plus, start here from 80, go over, shade that in just for consistency purposes, f of 80 times 20 plus, hit the curve, go over, and then hit the curve again and go over. Shade that in. I have 6 rectangles, so I have exactly what I need. F of 100 times 20, and then plus f of 120 times 20. I want you to notice that when we use the right Riemann sum, we actually end up using the right endpoint of the interval that we're focusing on, versus when we use the left Riemann sum, we definitely use the left endpoint of the interval, but we didn't even touch the right endpoint of the interval. We stopped at 100. So that's a little fun fact to keep in mind when you're evaluating the Riemann sums. So if you were to just start substituting things in, you can just factor out a 20 because all the terms are being multiplied by 20. You're not starting with 1.2, you're using 2.8 because that is f of 20, and you're just plugging things in and eventually evaluating them. And notice how this is kind of going a bit down, so this actually should be kind of like this, like a little bit downward here. So I'm just gonna modify that a bit. So it would actually stop here, but it doesn't change the fact that we are having an overestimation. So my apologies on that. But if we were to, and yes, this is supposed to be approximation symbol. Once we evaluate it, we get our final answer to be 532. And that's our approximation of our right Riemann sum using 6 subintervals. So if you have any questions or comments, please leave them in the comment section below, like and subscribe, and I'll make more videos later. Bye!